Hello, everybody. My name is Jonah Bregstone. I am a graduate student studying applied math, and I've been working as a technical researcher at the Native Bee Lab. And I'm presenting on a program the lab has been piloting that uses time-lapse photography for bee monitoring. So the team wanted to study bee flower preferences, and specifically native bees. And we wanted to come up with a method that was both low cost and not prohibitively labor intensive. Sam Droege and the other members of the team had this idea that we could retrofit recycled smartphones, deploy these phones into the Patuxent Wildlife Reserve, and take repeated photos of pollinating flowers in the hopes that we would document pollinator arrivals. And from this data, we could then estimate bee flower preferences. So how did this go? Well, what you can see here pictured on the right is an example of one of our prototypes. This is a recycled smartphone. It's strapped onto a camera tripod, and it's taking photos of yellow tick seed. The team has built this DIY shade cover that you can see that's protecting the phone from the Maryland sun. And over the summer of 2022, the team had about 12 of these prototypes that we deployed and took data with. So what happens with the photo data after one of our capture events? Well, the resulting photos are uploaded to a server, and the research team goes through two tiers of data coding. First, the team records pollinator arrivals. That is a photo where a pollinator has actually landed on the floral resource. Then secondarily, the bee ID experts at the Native Bee Lab come in and attempt a species level classification of the photographed pollinators. The histogram on the right shows the percentage of 3-minute intervals where our cameras observed first 0 pollinator arrivals, 1 pollinator arrival, 2 pollinator arrival, and 3 pollinator arrivals. And as you can see, most of the data that we collected over the summer is pretty uneventful. 91.5% of the time, a 3-minute interval will go by without us recording a single pollinator arrival. But about 8% of the time in our data, you'll see 1 pollinator arrival and smaller percentages for 2 and 3. So this data follows kind of the expected arrival distribution, but the question is it representative of the true distribution of pollinator arrivals? To study this question, the lab also recorded lots of video to complement our photo data. The lab analyzed this video to ascertain the true counts of pollinator visitation. We then wrote a program that went back and resampled our video, taking a frame every 30 seconds to simulate what would it have been like if we only took photos and what those photos might have gathered. The question we're asking is, how likely is it that the photo data set and the video data set's arrival data were drawn from the same probability distribution? And this type of question is answered with a statistical test like the Kolmogorov-Smirnov test, which gives you a p-value for that answer. We only have preliminary results right now. We're still playing around with our confidence intervals, but what we can say is that for 15 seconds or 20-second intervals, the tests are very positive. There's almost an exact match in the distribution of the arrival data between the true arrival count and our sampled rate. So what are the next steps? Well, the spring is here and we're looking forward to summer and fall, and we're planning to do more data collection during all 3 of these seasons. We're hoping to deploy more devices and in more places. And we hope to apply all the lessons learned from our 2022 analysis. That includes changes to how we collect the data, and it also includes changes into how we analyze the data. Finally, it's important to recognize all the various members of the team. The team at the Bee Lab includes Sam, Sydney, and Claire, and we had a great set of interns both summer and in the fall of Tashane, Raina, Amelia, Dorcas, and Austin. Thanks so much.